We're going to now look at determining side lengths using the cosine law. So we're going to apply the cos law, and we're going to hopefully explain how to use it. Okay, so the first question, what is side length A in triangle ABC? Well, notice in this triangle, I have a side, and next to it, I have an angle, and then I have immediately after that a side. So I have an SAS triangle, which means that I am going to be using cosine law. If I'm looking to find A, the way I have it set up is A squared is equal to B squared plus C squared minus 2BC cos angle C. Sorry, cos A. Getting a little ahead of myself there. So it's cos A. The angle and the unknown side have to be opposite each other. Okay, so that's always the case for a cosine. If this is little a, this has to be big A. So I am going to call this B, and I'm going to call this side here C, because they're opposite angle B, respectively, and angle C. So I type in I write in the letters that I know. So B is 67, C is 52, so it's 67 squared plus 52 squared minus 2 times 67 times 52 times the cos of the angle A, which I know is 61 degrees. So I can type that in exactly as I see it on my calculator. So I type in 67 squared plus 52 squared minus 2 times 67 times 52 times cosine 61 degrees. Make sure your calculator is in degrees. It has a little D or DEG at the top of the display. If it's a graphing calculator, under mode, make sure that your degree word is highlighted. And then when I hit enter or equals, I get A squared is equal to 3,814.8. It's A squared. So to get A, this is kind of like Pythagorean theorem. To get A, I need to get the square root of 3,814.8. So on my calculator, I type in square root, find your square root button. It might be a regular button, or it might need a shift or a second function key first. And 3,814.8 gives me an answer of, to the nearest tenth, 61.8 meters. So my options are either 38.8, 39.9, 59.9, or 61.8, and that's what I calculated. I calculated it to be 61.8 degrees. So that means that my answer is going to be D. Okay, we want to determine the length of side A again to the nearest tenth of a meter. So if I'm looking for A, once again, my cosine law is A squared is equal to B squared plus C squared minus 2BC cos A. And I got it right the first time this time. Whatever side I'm looking for, I need to know the opposite angle. So once again, it doesn't matter. I'm going to call this one here B and this one C, but it really doesn't matter as long as we have both sides included. A squared is equal to 23 squared plus 16 squared minus 2 times 23 times 16 times cos of 40 degrees, because angle A is 40 degrees. So once again, on my calculator, I can type in exactly as I see it there. 23 squared plus 16 squared minus 2 times 23 times 16 times cos 40 degrees And again, seeing as how we're doing this immediately after the last one, I think it goes without saying your calculator should be in degree mode. When I hit enter, I get 221.2. So a squared is equal to 221.2. To find a, I need to get the square root of 221.2. So a is equal to square root, so it might be a second function or shift key, or it might be in just a regular key on your calculator, of 221.2. Works out to, for me, 14.8725. So a is equal to the nearest tenth, 14.9 meters in length. So once again, I used cosine law because I had two sides and I had the angle between those two sides, or the contained angle. So the cosine law is also used, much like the sine law, if we don't have a right triangle. We can find a missing side length using cosine law if we know two sides and a contained angle. They're SAS triangles. The cosine law for triangle ABC, if I want to find side A, is a squared equals b squared plus c squared minus 2bc cos angle A. If I want to find B, it's b squared equals a squared plus c squared minus 2ac cos angle B. And if I want to find C, it would be a squared plus b squared minus 2ab cos angle C.